right, so yeah, I'm Zachary Berry. This talk is about creating a video synth, or synthesizer with JavaScript, and of course, the browser. A little bit about me, thanks for the introduction. Yeah, I work at UCF, and obviously I love JavaScript in the browser, which is why I'm here. Yeah, I submitted my proposal on the last day, kind of like a what the heck, why not? Really didn't think I'd be picked, and yet here I am. So that's why this was the official photo that I gave the conference. This was my family. I was visiting back home in Panama City Beach, and my parents were like, hey, come down to the beach, and this was the result. And I promise this wasn't intentional, but that is indeed a JSConf 15 shirt. Yeah. So I'm super thrilled to be able to visit the conference in Amelia Island and now to be able to present. So that's super cool. And I promise it was not intentional. OK, so the inspiration for this idea, we're going to start off with a little experiment. This is some code that I'm going to try to run through real quick, and I'll show you what it does. It's going to take the whole body element, and it's going to shove it into a marquee, which I don't know if you knew this, but marquee does have options, so you can speed it up and reverse it. We're also going to select all the spans and H1s, and so have you. And then on each of those, we're going to put those in a marquee because we can. And then we're going to make an angle variable and then set an interval, and then we're just going to increment that for every div on the page. And we're going to do that every millisecond. So let's see, we have JSConf. Let's run this and see what happens. So it'll come back around. Yeah. And it's a little bit fast, but you can still use it. If I was able to click on a button, it would still work. I tried it. I'm not going to try here because it's hard. But enough of that. So what was the point of that? Right? The browser is a powerful rendering engine. I'm kind of surprised that you can put a marquee and a marquee and a marquee, and you can rotate the whole page in it. For the most part, handles it. And the marquee tag still works. Backwards compatibility is awesome. So I'm kind of trying to lay out like kind of the concept of the idea. That's one little piece of my brain. The other piece is something that I've been kind of excited about, which is modular synthesis. I'm kind of excited yesterday or not yesterday, but the first day of talks, someone did have a photo of like a modular setup, which was really cool. I will let Andrew Huang, a famous YouTuber, explain, because he can explain it better than I can. So let's see if this works. Oh. Maybe. Let's see if I can turn this up. OK, well, no. But I'll try to explain it then. So each of these pieces is a little module, and you can plug them together. So some of them create audio, so it's just like a simple sine or square waveform. Others can then manipulate and manage that audio and transform it in different ways. And let me advance. Where's my mouse cursor? OK. OK. All right, let's see if I can. Live demo. Here we go. Speaker. Sound, thank you. This is crowdsourced. OK, so output should be headphones. OK, all right, thank you. All right. All right, so how this relates to JavaScript. So modular synthesis is composed of several modules, and those take input and give output. It's a little bit of a stretch, but that's kind of like how functional programs are made. You kind of combine and compose several functions. They take input and give output. Third piece of my brain is I had started producing music, electronic music, and I needed something to put into the SoundCloud little thumbnail thing for album art. So I wrote this application that generates SVGs dynamically. And so if I clicked on one of these, it would download a 2000 by 2000 PNG And I can reload just to show you it's live. So that was really cool. I was pretty happy with that. But the code is terrible. And when I would have to go through and edit the code to like make changes. So like maybe I didn't like this one color. I wanted there to be more circles and more lines. And that was kind of a tedious process. And I thought it'd be really cool if I could tweak these parameters live with some sort of user interface. And then I showed you modular synthesis, or at least I tried to explain it. Audio is another signal, and so is video. So you can do the same type of thing with video as well. So this is a video modular synth, and it can like take the red channel, and then you can manipulate that and transform video in different ways. Hopefully this works, but this is a friend of mine who has a huge video modular setup. This is a little demo of him kind of tweaking some parameters live. So he's changing the effect of the video here. And so it's actually not that new. The first visualizer, as far as I understand, was back in 1977 with the Atari video music. And that is the same Atari that you're thinking of from like the 2600. And to my knowledge, the first time it was used was in the background of a Devo video, so I figured I'd show it to you. So basically, the Atari video music works by it takes audio signals, and then it's its little black box, but it makes these diamond patterns and weird squigglies. And this was a good example because some of the stuff can be super flashy. I didn't want to show that. But there are a few parameters you can tweak to then modify how that works. So all this stuff is really cool. I love it a lot. And it's very kind of this VHS lo-fi 90s, 80s kind of thing. But I also like very digital type of aesthetics. So here's two examples of some of that. Hopefully. That's one, and then here's the other. So as you can see, that's kind of reacting to the audio. It's very purposely built to do that. But that got me thinking, it'd be really cool to be able to create these videos live as I was performing music. And they're simple to the point that, at least graphically wise, they're simple, so that I could totally make these with like a Canvas or SVG application. And then going with that, it's crazy how much, again, with the power of the browser, we have CSS animations, 2D, 3D graphics, we have SVG, we have video, we have awesome libraries like 3JS, Pixie.js, and this is obviously just two in a huge multitude of libraries. And we have all these APIs, and some of the talks that you've seen here talk about some of these cool APIs. So why don't we harness this technology? And so that's the idea. So let's see. Oh, right, this is not my app yet. This is another slide. Okay, so and then the idea here is that we have all this types of hardware, and all of this hardware sends different signals. So here I have a PS4 Gamepad. You can see that. And the mouse, audio, this is like reading the audio level from the MacBook. And then those are MIDI messages. So wouldn't it be cool if we could then harness all of those kind of as a signal, kind of like drawing inspiration from the video modular synth. And each of these can be harnessed through different APIs. So Gamepad is Gamepad API, obviously. Media capture and streams here is just for audio, but you can also do video, which I'll show you in a little bit. And then those can send signals over to some sort of application. That application can harness those libraries and those web APIs. But what we could also do is that we could, at least the idea is to remap those live, so we could change the configuration and then change the visualization as a result. So let's get into that. So this is what I built. It's an application called BitKid. Let me see if I can make it bigger. The idea is that we have kind of a software version of a visual synth. So here we have the mouse node that's reading the DOM events from the mouse. And then as I move back and forth, it's changing these X and Y values. And those are being put into the display up there, which I am calling the screen. So if I full screen here, you can see it's simple. It's just showing you the pixel values. But what I can do is an example is, let's see, transform. Whoops. Actually, this is a good example. So all of those nodes are just JavaScript, and they're kind of inspired by web components. They actually are web components, but they use their own lifecycle methods. So anything that you see in the node can be changed. Up here is the inputs. So those can be defined with like what kind of a value they accept, as well as other options. So let me put these together. And what I'm going to do is I'm going to hook up the X value of the mouse to rotate our screen. So with that little change, I'm able to now, the mouse is kind of controlling the CSS rotation of this element here. So just a quick overview of how it works. This is what I said, this is the screen element. These are what I call nodes. Each node has optionally a list of inputs and a list of outputs. There's also the web component that I spoke about. And then each of the inputs optionally has a UI that kind of lets you set the values if you don't set them through some sort of hardware method. And then those can be connected. And how it works is each of those, like I showed you that code, that's the node.js, I don't mean the framework node, but I mean like the JavaScript that makes up each node. And then those get evaled into basically a web component class. And then I have a CSS and HTML, which then gets put into a shadow root. And then those combine into my custom web component that I built for this. And then we have a React layer, which then that was what's the graphical interface of connecting all of the nodes. But it also, each React component has a native web component in it, which is kind of a nightmare. And then we have the state, which this is very simple, but simplified view, but it's basically what node is connected to what node and what are the values at any given point in time. And then we have the screen element at the upper right, and that's just a web page. That's HTML and CSS, and that gets shoved into an iframe. So I wanted to talk a little bit about some of the technology behind it. Web components, I'm sure a lot of you have seen it, but just in case you haven't, you can make any sort of class extend HTML element or other HTML elements if you like the paragraph tag. And you get these lifecycle events. So you get connected callback, that's when it gets attached to the DOM. Disconnected is when it gets removed from the DOM. Adopted means it's moved to another document. But the one that I'm really harnessing here is observed tributes. So what you can do is you can define different attributes on the HTML element, and then you get a callback that gets fired whenever those attributes change. And just real quickly how you would use it, you might make, like, for example, a user icon web element. You would define it using custom elements.define. I should say this only works, I believe, in Chrome, and I think it's coming to Firefox soon, and there's some polyfills. But you say, whenever I see a user-icon tag, I want you to use that user icon class, and then you can make your custom element. All the code examples I'm going to be showing, you can get to with this bit.ly URL. I just have a CodePen collection of a bunch of kind of the basics of what I'm showing you, if you're curious. So writing to the iframe is actually surprisingly easy. And one of the examples, I have CodePen in CodePen, because all you need to do is you can get an iframe element, you can open it, document.open, you can shove a bunch of HTML in there. You can then create a new style element, and then you can just put that into the head of the iframe that you just created. So it's kind of hacky, but what's great about this is now you've sandboxed it. So if you write some weird HTML, I don't have to worry about it throwing errors. The iframe will just kind of sort of deal with it. So I heard some of you laugh with eval. This is a famous kind of thing from Douglas Crockford where he said eval is evil, and basically you should never use it. But I wanted to make kind of a little amendment. except when it's used in a weird art project. Then you're good. At least you have my permission. You can blame me. In fact, it's a little punk rock. Because it's kind of impressive that you can do this with a language. So here's how to be evil. Eval, maybe you've avoided it for so long you actually don't know how it works. You can give it a string of text, and then that will be parsed as JavaScript runtime, and then you'll get back, for example, here I'm returning or setting the value of x, I can then get that value back out. And then how to be a little bit less evil is you can use new function, which is actually what I am using. What's really cool is you can pass attributes as strings to function, and then the last attribute can be code. And then when you execute that function, here it returns the expected result that adds these numbers. So I'm not saying that you should probably go out with your Equifax JS server-side application and start evaling everything, because it's incredibly inefficient. But for what I needed to do, it was perfect. OK, so the real point of what I was trying to do is I was trying to combine CSS transitions and drum machines. So I will show that here. I have a webcam. Oh, let me switch. There's my face. Oh, it's not connecting. 1 second. This was kind of a weird talk because I just jammed all the technology I could find into a talk and hoped it would go well. Let me refresh this page. OK, unfortunately, no. Well, trust me that I have a drum machine up here. It's the Roland TR-8S. So with this example here, what I have is I have a bunch of circles. So when I click this button here, these circles will just change. They're setting to a random size and position. And to get back to what I was talking about with the screen, this is that screen. This is just plain HTML. This is what I shove into the iframe. And then the thing that makes it work is just this transition here. It's just a 200 millisecond animation. So I could change that if I wanted to. But it's not just about clicking the button. It's about connecting the hardware. So what I can do is I have a node here that takes the MIDI messages from here and splits it out into different channels. So I know you can't see this, but it's split between bass drum, snare drum, and all the different sounds. So what I will do is I will hook up the bass drum to this guy. And each of these nodes I'm connecting it to, those are just, I'll show you. Those just, oh wait, sorry, that's just to show you. Those all connect to the circle guy, and the circle simply just sets the attribute of the ID or the element, sets the X, Y, and the scale of them. So if this works, I'll be happy. Oh, sorry, I didn't finish connecting everything. All right. So let me show you patterns. It's going to play. Thank you. Thank you. Whatever reason, the pink one doesn't want to cooperate. But so when I hit these buttons, it's just changing. Not all of them are mapped. So that's the idea. Thank you. OK, so this is just another example. This is just a static set of SVGs, but they have two different states. So when they listen to the, and then I can add the, oh, sorry. Yeah. Thank you. And again, if I show you that, it literally is just SVGs baked in straight from Illustrator. I didn't indent it. You know, who cares? It's an art project. That's fine. Let me close this. OK. So MIDI, there were some talks already about MIDI. On the first day, there was talks about Bimini, which is a super cool project. It's kind of confusing because there's MIDI as MIDI files. Those are kind of like play sound. What I'm talking about here is MIDI signals. So pretend that you are an electronic music composer and it's 1981, and you have a keyboard, a synth, and it plays awesome sounds and it's really cool. But then you're like, okay, I need to enhance my sound, so I want some drums to go with this. So you get a 1981 drum machine, and it sounds awesome. Then you get something else because you're addicted and you buy too much stuff. The problem is that they all speak their own language. So when you want them to talk together, they can't. And then in 1982, the MIDI standard comes about to solve this problem, and now everything can play together. I realize I think I have flux on, that's why things look orange. There we go. Okay. Okay, so how that works is you have your keyboard, right, and you play a note and it makes a sound. But if it's MIDI enabled, it also sends out a message. So it's going to say, hey, you've played middle C. And then you play a lower note, and hey, you've played F. And I don't want to go super in-depth into it, but the message is just data. It describes, like, you press note on, that's the type. Channel, there can be 16 channels, how hard you pressed it, and that's just binary. And there's tons of different messages. I don't want to cover them all, but like knobs and clock and tempo and that thing, that's all there. But what's great is that you can connect to that through web MIDI. And what that looks like is you request MIDI access, then you get the MIDI access, and then for each of the inputs, you can just listen for a MIDI message. And then you get back event.data is just a special array that has those 3 bytes that I showed you on the previous slide. And that's it. It's super low level. It's great. I forgot to show you the Gamepad demo. Actually, maybe do that. Oh, no, that was a bad idea. Okay. And so here I have the Gamepad mapped. I saw it for a second. There we go. Okay. So I have this Gamepad here. This is just a PlayStation 4 controller, and I have the axis here defined to then set the background. Probably wasn't important to show you that, but I did. All right, remember this part? Okay, we're going to get through here. Okay. All right, yeah, so how that works is you can just listen for Gamepad connected. You can get the index, because there's basically, I think at least on Chrome, there's kind of 4 slots that those Gamepads go into. And then you can request animation frame. You basically are going to poll for the values of that. So here you can get the Gamepads, and you do that each time. And then you can log out the values of the axes or the buttons. It's just a number from -1 to 1. And then you just keep polling. So super easy. Next is video in Canvas. Oh, that's weird. I've never had that happen before. Let me try connecting this to another USB port, and maybe that will solve some of my problems. Live demo. That seems promising. Sweet. Okay, all right. So I'll show you this. What this is this is just reading my webcam, but there's a layer on top that is putting it to Canvas, and then on Canvas, it's reading the pixel values and then just summing up the color of that pixel, just because why not? It looks cool. So hello, JSConf. Can't make you guys out. So yeah, that's what this looks like. To show you the code behind that, to grab the webcam is also pretty easy. You ask for user media, you ask for video, you get a stream back, you can dump that into a video element and just tell it to play and it works. And then of course error callback, which you saw in my demo. Canvas is easy as well. I'm sure Canvas has been out for a while, so you probably mess with it, but just in case you haven't, you can make a Canvas element, you can make a video element. You get the context, this is how you work with Canvas, and then you can draw onto the context, which draws onto the canvas, an image, and that first attribute is our video tag, so that's what I'm dumping the webcam into, and I'm just reading it back off of that. And then I can do whatever I want. So here's just an example of how to grab the color of a single pixel. And here's another video example. And this one should work with MIDI. So let's try it. Change pattern and start. OK, so what this does is when it hits a kick drum, it's going to flash the screen. But when it gets that chord sound, it's going to randomly rotate with a rotate Y, a CSS transition, the whole thing. And on top of that is my pixel canvas. And I'm kind of changing the height based on perspective where that is. And hopefully this keeps going. Thank you. Thank you. So thanks for being in the first JSConf music video. All right. So what are the problems with this approach? I don't want to get too into it because it's nasty and annoying, but putting a web component in React is a terrible idea. The virtual DOM and the way React works, I think it somehow triggers those connected and disconnected callbacks all the time. So I just can't use them. I tried to get around it for a couple of days, and I ran out of time. I was like, OK, I'm just not going to use it. So instead, then you just don't use them. Another problem is the nodes are all evaled. If you edit a node and then save it, that causes a problem because the custom element is already defined, and I can't redefine it. So you can just append the date to the name of the tag that you create, and you're good. Get attribute in the element always returns strings. That's just kind of how get attribute works. So I don't use it. I get around it. So I have my own get attribute function, and then I have the native one that I've overridden that you can still get to. You also can't, at least I couldn't catch the errors. So when you wrote like some JavaScript in the app and then it ran and then you got a value, it would throw an error. The whole thing would kind of just die. So I needed to basically wrap attribute change callback, and so I have my own attribute change callback as well. Performance, get a faster computer. Actually, no, I did do a little bit of work with this. So React has should component update, which lets you try to optimize. The truth is I didn't get that far into it, and there's only so many request animation frames you can run before your browser crawls, but that's future work. So yeah, there's a lot of problems. Whatever. Prior art, if you've done any sort of visualization stuff, this probably looks somewhat familiar. Turns out there's a lot of things that do this. When I started out, I was thinking, oh man, this is really cool. I've never seen like a visual, like modular software. No, there's lots of examples. But these are really cool, especially I just recently learned about TouchDesigner. It looks super awesome, so I recommend you check it out if you're interested into this. Last example is I have a very cheesy synthwave song with a demo, so hopefully this works. So that basically just treating this grid thing as input and output. I have these walls here, so it's a little bit hard to see, but up in the corner, I can trigger the walls. I can trigger the background. So all the examples have shown hardware talking to JavaScript. No, I don't use. But you can use a Loopback MIDI device for the software to talk to itself. So this is a logic file, which I will play. So the walls are done on every drum hit, and the background is also pulsing with the drum hit. And I'll use a hue rotate CSS transform in a second on the MIDI notes that come in to change the color. And then after that, there'll be one more thing. So. That's as far as I got in the song, but that's the idea. Thank you. Again, that's all the code examples. The app is at vidkid.app. It's on a super cheap DigitalOcean box, so it might crash. The code is public. It's at vidkid. I'd love to get pull requests. It was made on a deadline for this, so it's a little bit rough. I don't really use Twitter that much anymore, so if you want to follow me on Instagram, I'm at zap_danger. And that's all I have. The only thing I didn't show you was the audio, so you can also read the microphone and put it in there. So that's all I got.